We're going to finish 10-41. So open up to question 1041 in Unit 10, Section 10.1.4. And draw the diagram for D. If any part of A, B, or C wasn't clear, please come in and see me to go through those exercises. We're going to label the vertices of the chords. Remember that chords are segments with endpoints on the circle. And remember that secants are lines that intersect the circle at 2 points. So a secant contains or is a line containing a chord. We are told in this problem that HJ and IK intersect at point G, and I should say segment HJ and segment IK intersect at point G. We're told that HG is 9, and we're told that GJ is 8, GK is 6, and we're asked to find JG. Mark what you see. We have a pair of vertical angles at KGJ and HGI. And remember the questions we're keeping in mind. Those are there any arcs that can help? What type of angle is that? What do we know about angles formed by parallel lines? And how can that help here? And let's see what we have. Now I like that in this exercise it is clear that KJ and HI are not parallel, at least from this drawing, because we have done some similar triangle exercises that look like this. But what we're going to find, or at least want to investigate, is these two angles. Are they congruent? Well, these are both inscribed angles, and they both intersect the same arc KH. Therefore, we know that those two angles, the angle at J and the angle at I, are in fact congruent. So we can use angle-angle similarity to set up a proportion. So we have triangle HIG similar to triangle KJG. We can say that 9 is to 6 as the unknown is to 8, because KG corresponds to HG and GI corresponds to GJ. And let's use X in place of GI. We can bust the fraction with 24. For X equals, I'm going to rewind. We can bust the fraction with 24. But my 3 is on this side, and my 3 is on this side, and my 4 is on this side, because 24 divided by 6 is 4. And 24 divided by 8 is 3. 3x on the right, 36 on the left. Divide both sides by 3. We have a value of 12 for GI. So we use similar triangles from Chapter 3, new circle insight from Chapter 10, and proportion insight using cross products if you've earned the license. And let's take a look at the next circle. In that illustration, E is the center of the circle. A and C are endpoints of what must be a diameter because it is a chord that passes through the center. And B, A are connected. We're told that AC is the diameter. We're told that the area equals 289 pi units squared. And we're told that AB equals 16 units. I see that this triangle is inscribed in a semicircle, which makes this a right angle. I'm not sure if that will be important, but it just might be. We're asked to find BC and the measure of arc BC. So we need to find this distance from B to C. And we need to find the measure of this arc BC. So let's go ahead and see what we can find out by completing this menu for this circle. R, D, C. Can we work backwards from the area to find any of these values? Area formula equals pi. Well, here's pi multiplied by r squared. So 289 must equal r squared. R then equals the square root of 289. So r must be 17. D must be 34. Circumference must be 34 pi. So we have a value for AC, the diameter of the circle, and we can use that value to help find BC. So go ahead and press the buttons to find me those values. BC equals the square root of 900. Well, that's a handy one because the square root of 900 is exactly 30. Oh, now I need to find central angle BEC in order to find the measure of arc BC. So let's see if we can work with this isosceles triangle. Where we have side length 17 and a triangle with one leg 15, one hypotenuse 17, and is that enough to find us some angle measures here? This is the angle we want in order to help us find the arc that lives here. If we know what theta is, we can calculate two thetas. So with an opposite and a hypotenuse, let's use the inverse sine with the ratio of 15 over 17 to find this angle. go ahead and push those buttons and find me an angle that has ratio of 15/17, that has sine ratio of 15/17. I have an angle at theta approximately 61.93. Let's not round to the hundredths place because we're going to have to multiply this and we don't want to multiply too much error. So theta is approximately equal to 61.93. That makes this angle 2 theta. 2 theta is approximately 123.86. Therefore, the measure of arc BC is approximately 123 86 degrees. And one last circle problem we're going to look at is the circle in FACB, where the angle at B is marked at 65 degrees. It looks like arc BC in the textbook is marked at 112 degrees. We're told that ABC is inscribed in a circle, and using just these measurements provided, we're asked to find the measure of arc AB. So what do we know about arc AC then? We have this guy, and we have an angle inscribed in arc AC. If that angle is 65, then the measure of arc AC must be 130 degrees. We know the whole circle measures 360 degrees. So let's subtract 130 and let's subtract 112. That'll give us the measure of arc AB. Go ahead and push those buttons or do that subtraction to get me a value for the measure of arc AB. And there we'll find the measure of arc AB is equal to 118 degrees. Which must mean there's a central angle, whoops, missed B. There's a central angle with the corresponding degree measure, and it must mean that the angle at ACB is 59 degrees. So we could continue to work around this triangle and find missing measures, which sounds like a lot of fun.